Welcome to Joey's Tech, my friend. In this video, I am going to explain to you the shell sort algorithm. I am going to tell you first how it works. Then I am going to tell you how to implement this algorithm in a Java program. And finally, I will tell you its time complexity. But before that, I need you to subscribe to my channel if you haven't already, because that way you won't miss out on these coding and algorithms videos I create for you. Also check out my sorting algorithms playlist, in which you'll find videos created by me on several important sorting algorithms. This is our problem array that we'll be sorting using the shell sort algorithm. But before we begin sorting it, let's see quickly what the shell sort algorithm is. Shell sort algorithm is a variation of the insertion sort algorithm. You can watch the video I made explaining the insertion sort algorithm by clicking on the I button. Now, in the insertion sort algorithm, what happens? The algorithm moves elements only one step ahead. That involves many movements when an element has to be moved far ahead. Now, shell sort algorithm overcomes this limitation by sorting the elements that are far from each other, separated by an interval. It then successfully reduces the interval between the elements to be sorted. Remember the word interval here, it's of immense importance when it comes to shell sort algorithm. Now, the interval between the elements is decided as per a sequence and is reduced as per that sequence. So the optimal shell sort sequence is this. So when n is 8, the first interval that is going to come out will be 8 divided by 2, which will be 4. The second interval will be 8 divided by 4, which is going to be 2. And the third interval is going to be 8 divided by 8, which is going to be 1. Is it confusing? Don't worry, you will understand everything. I know that this theory is a little bit overwhelming at this moment. Therefore, let's start understanding the shell sort algorithm right away. So what is n here in our problem array? That means the number of elements. I see the number of elements as 8. So n is going to be 8. So the first interval that will be calculated will be 8 by 2, which is going to come out as 4. So in the first iteration, the algo is going to start from the element at index 4. And in this first iteration, it is going to continue all the way to the last element of the array. So at index 4, we have 5. The algo is going to compare it with the element that is 4 places on the left of it. So 4 minus 4 is 0. So at 0th index, the algo is going to go and compare the element over here with the element at this index, which is 4. So 9 is greater than 5. So what the algo will do, it is going to assign 5 to a temp variable and put 9 in the cell at index 4, like this. And at index 0, the temp variable's value, which is 5, will be placed by the algo. So let me put 5 over here. Basically, a swap has happened. Now the algorithm is going to shift to the next element, which is at index 5. The value here is 6. It will be compared against the element which is at index, that is the result of 4 subtracted from 5. So 5 minus 4 is 1. That means 6 will be compared against 8. Okay. Now since 8 is greater than 6, hence 6 will be placed in the temp variable. 8 will be picked up by the algo and will be placed over here instead of 6. And the value of temp variable, which is 6, will be placed over here at index 1. Okay, another swap has happened. Now the algorithm is going to move to index 6. Here the element is 4. 4 will be compared against the element that is at index 2, which is calculated by subtracting 4 from 6. So the element at index 2 is 3. Since 3 is not greater than 4, hence no swap will happen. The algorithm is now going to move to index 7. Here the element is 1. It will be compared against the element at index 3. 7 minus 4 is 3. That is why. So the element at index 3 is 7. Since 7 is greater than 1, hence the swapping has to happen. So 1 will be assigned to the temporary variable. 7 will be placed at index 7 and the value of the temp variable, which is 1, will be placed at index 3. Okay, this completes the first iteration where the gap or the interval was 4. The gap is going to further reduce now. N will be divided by 4. 8 divided by 4 is going to give out 2 as the quotient, and therefore the gap will become 2 now. The algorithm is therefore going to start from index 2 in this iteration. So the value at index 2 is 3. And it is going to be compared against the element at index, which will be the result of 2 minus 2. 2 is the index and 2 is the gap. So 2 minus 2 is 0. That means 3 will be compared against 5 because it is the element at index 0. Now 5 is greater than 3. So 3 will therefore be assigned to a temporary variable. 5 from here will be picked and will be placed by the algorithm here at index 2, and the value of the temporary variable will be placed at index 0. Hence the swapping has happened. Now the algorithm is going to move to index 3. Here the element is 1. It will be compared against the element which is at index 1 because 3 minus 2 gives us 1. Here the element is 6. Now 6 is greater than 1. So in this case 1 will be assigned to the temporary variable and 6 will be picked and will be placed here at index 3, and 1 will be placed here at index 1. Successful swapping happened. Now the algorithm is going to move to index 4. Here the value is 9. It will be compared against the element which is at index 4 minus 2. So the element at index 2, which is 5. Now since 5 is not greater than 9, hence no swap is going to happen. The algo will now move to index 5. It will be compared against the element at index 3, which is the result of 5 minus 2. So the element here is 6. Since 6 is not greater than 8, hence no swap happens. The algo is now going to move to index 6. Here the value is 4. Now it will be compared against 9, which is at index 4, which is calculated by subtracting the gap 2 from 6. So 9 is greater than 4. Hence what's going to happen? 4 will be assigned to the temporary variable and 9 will be picked up and will be placed over here at index 6. Okay. Now here comes the tricky part in shell sort. The comparison is not going to stop here. It will further continue. And it is the case with every comparison that we have performed so far. But since we have got this use case for the first time, that is why I am explaining it to you now. So the value of the temp variable will stay as 4 and it will be compared against the element that is 2 cells away from here. That is the element at index 2. 2 gets calculated when we subtract the gap 2 from 4. So 4 will be compared against 5. Now since 5 is greater than 4, hence 5 will be placed here in this cell at index 4. Okay, and the comparison is going to continue further. This time the value of the temp variable, which is 4, will be compared against the element that is 2 cells on the left from this particular cell. That means index 2. So what will be that index? It will be index 0. The value at index 0 is 3. Is 3 greater than 4? No. So the comparison will stop now and the value of the temp variable, which is 4, will be placed at index 2. Okay. Basically what the algo did, it placed 4 at its correct position by comparing it against the elements at intervals of 2. The algo will now move to index 7. Here the value is 7. Now it will be compared against the element at index 5, which is 8. Since 8 is greater than 7, hence 7 will be placed in the temporary variable and 8 will be placed over here. The comparison will further continue. So the value of the temporary variable, which is 7, will be further compared with the element that is at a gap of 2 cells from this index 5. That means at index 3. So the value at index 3 is 6. Now 6 is not greater than 7. This is an indication that no swap is required. The comparison is not going to proceed further and the value of the temporary variable will be placed here at index 5. So let me place 7 over here. And this completes the second iteration. In iteration 3, the gap will further reduce. This time n will be divided by 8. So when 8 is divided by 8, we will get 1. That means the algo will begin from index 1. At index 1, we have 1. So it will be compared with the value of the cell which is at an index of 1 less than the current index. 1 minus 1 is 0. So 1 will be compared against 3. Now since 3 is greater than 1, hence 1 is going to go to the temporary variable. 3 will be placed here at index 1 and the value of the temp variable, which is 1, will be placed at index 0. Alright, now the algo will move to index 2. Here the value is 4. So 4 will be compared against 3, which is on its immediate left. Is 3 greater than 4? No. So the comparison will stop here. It won't proceed further and no swap will happen. Now the algorithm is going to move to index 3. Here the value is 6. It will be compared against 4. Is 4 greater than 6? No. So the comparison will stop here and no swap will happen. Now the algorithm is going to move to index 4. Here the value is 5. Now it will be compared against 6. Is 6 greater than 5? Yes, it is. So 5 will be placed in the temp variable and 6 will be placed here at index 4. Okay, now as we have seen in the previous iterations, the comparison will not stop here. The value of the temp variable, which is 5, will be compared with the element that is in the cell on the immediate left of this cell at the gap of 1. So at index 2 we have 4. Now is 4 greater than 5? No. So the comparison is going to stop here and the value of the temp variable, which is 5, will be assigned to this cell at index 3. Okay, now the algo will move to this index, which is 5. Here we have 7. It will be compared against 6. Is 6 greater than 7? No. So the comparison will stop and the algo is going to move to index 6. Here the value is 9. It will be compared against 7. Is 7 greater than 9? No. So the comparison is going to stop and the algo is going to move to index 7. Here the value is 8. It will be compared against 9 because it is at a cell which is at a gap of 1 from this cell. So is 9 greater than 8? Yes, it is. So 8 will be assigned to the temp variable and 9 will be placed here in the cell at index 7. The comparison won't stop. The value of the temp variable will be compared against 7. Now is 7 greater than 8? No. So the comparison is going to stop here and the value of the temp variable, which is 8, will be assigned to the cell at index 6. And the algorithm is going to stop because it has no further cells to jump onto. Alright, and what do we have here? After iteration 3, the array is completely sorted and we have sorted it using the shell sort algorithm. Alright, now let's implement the shell sort algorithm in Java. Alright, so within the main function, I'm going to first declare and initialize an array. So let me do that quickly. It will be an integer array. I'm going to name it data and it's going to contain the elements as 9, 8, 3, 7, 5, 6, 4, 1. Alright, now I'm going to create an object of the shell sort class. So it will be shell sort. I'm going to name it ss and it will be new shell sort brackets. Okay, now using this object I'm going to make a call to the shell sort function. So it will be ss dot shell sort. Let me name that function like this, and it is going to accept array as the first parameter, and the second parameter that it's going to accept will be the size of the array. So it will be data dot length. All right, now I'm going to write the code to print the array. This is going to print the array in the sorted order. So I'm going to write system dot out dot println sorted array and in the next line of code I am going to print the array. So it will be system.out.println arrays dot toString. Let me use the inbuilt Java function of the arrays class to print the array. Okay, now it would be better if we printed the array before calling the shell sort function to highlight the difference between the sorted array and the unsorted array. So let me change the message to problem array, and this is going to stay the same. Okay, it's this line of code that is going to make the difference. Now let's write the function shell sort. So it will be public void shell sort, and the first parameter is obviously going to be the array. I'm going to name it ARR, and the second parameter will be n, which will be the size of the array. Alright, now we will write the first for loop that is going to perform these iterations. Alright, so I'm going to write for, and the variable I am going to name it as interval, and it's going to start from n by 2. Remember, it started from n by 2 over here, and the end condition will be interval greater than 0. Alright, it went till 1. After this iteration, the interval would have been n divided by 16. So 8 divided by 16 would have obviously given the quotient as 0. Therefore, no further iteration happened, and the increment step will be interval equals to interval divided by 2. Okay, I think this is very much clear. Now within this for loop there will be another for loop, and it's going to start from the interval calculated. So if you remember, in iteration 1, interval calculated was 4 and the operation started from index 4. In iteration 2, the interval calculated was 2 and the operation started from index 2. So it will be for int I equals to interval. Alright, so when the operation started from the index represented by the interval, it continued till the last element of the array in steps of 1. So the end condition will be I less than n, and I increment operator will be the step condition. Okay, now the element represented by I needs to be compared against the elements at intervals represented by the variable interval. So it will be better if we assign the value represented by I to a temp variable. We did that already, right, when I explained the algorithm to you. So it will be int temp equals to ARR within square brackets I. Alright, now we'll write the for loop that will be responsible for performing the comparison of the value stored in the temp variable against the elements that are located at gaps represented by the variable interval. Alright, also within this for loop we are going to write the code to perform the swapping of the elements or placing the elements that we find greater than the value of the temp variable at the correct position. Okay, so for that I am going to first declare a variable j, and I am going to start the for loop in which I am going to initialize j to I. You will come to know in a while why we did that. Now let's first write the step condition. So the comparison is going to happen with the elements that are located at gaps represented by the variable interval. So the step condition will be j equals to j minus interval. Okay, now here comes the tricky part, which is the end condition. Now when the comparison would proceed further towards the left, it would stop at two conditions. Number one, for example, if the gap is 2 and if the pointer is at index 2, the value will be compared against the element at index 0, and that will be the dead end. After that, the comparison cannot proceed further towards the left. because after 0 on the left hand side there is nothing. Alright. So the first condition will be that j needs to be greater than or equals to the value of the gap, which is represented by the variable interval. And the second condition which would stop the comparison is when the value of the temp variable is greater than the element against which it is compared. So it will be AND operator, ARR, j minus interval. This would give the element at the index against which the value of the temp variable is compared. It has to be greater than the value of the temp variable for the execution to go within the for loop. So in other words, for this loop to run, j has to be greater than the value of the interval variable and the element against which the value of the temp variable is compared, that element has to be greater than the value of the temp variable. If so, then the element located at a gap represented by the variable interval from j will be placed in the cell represented by j. So it will be ARR within square brackets j equals to ARR within square brackets j minus interval. Alright, that's it. And finally, after the loop is over, the loop is done, that means the comparison has stopped, we will have to place the value of the temp variable at its correct position, and it will then be represented by the variable j only. Okay, so it will be ARR within brackets j equals to temp. Okay, and that's it. The program is over. We have just written a Java program implementing the shell sort algorithm, and now it's the time to run it and check whether it is able to sort the problem array or not. So let me quickly run this program, and there you go. The program ran successfully and it has sorted the problem array using the shell sort algorithm. The program is working completely fine. And how can a video on a sorting algorithm be over unless I tell you about its time complexity? So the best case time complexity of the shell sort algorithm is big O n log n. The average case time complexity is also big O n log n, but the worst case time complexity is big O squared. With this, we have come to the end of this video. I hope you enjoyed learning the shell sort algorithm from Choice Tech. Do watch the videos on other sorting algorithms that I have created. In order to learn them properly, you must watch them. I'll see you in the next video of Choice Tech. Till then, goodbye and take very good care of yourself.